1 centimeter equals to 10 millimeters. So these are what we call the primary conversion factors, and there are secondary conversion factors. Given the primary conversion factor, you will be able to figure out the secondary conversion factor. One of the primary focus of this course when you're doing calculation is to determine the conversion factor. Once you determine the conversion factor, the rest of them is easy. Just plug in the conversion factor, pay attention to the unit, cancel out the unit you don't want, you will end up with the unit you do want. So that's something that you want to pay attention to. So the list of equivalent quantities there, it's not something that I want you to memorize. There's no point to memorize all of them. But some commonly used ones, you probably want to remember them. That will save you some time and to your benefit. When you're taking an exam, if you don't know the relationship between meter and centimeter, you have to look it up. That takes time. Time is something you don't always have when you take an exam there. So it's to your benefit if you can memorize some of these, and that's great. If not, you need to know where to find the information. Okay? So we give you all these list quantities there, and remember when you're doing homework and you have access to this, and there's another thing that you can use. It's a little thing called internet these days. So if you don't know how to do conversion there, you can always Google the conversion and plug in the conversion factor and do a calculation. And unfortunately, you are not allowed to use your cell phone or computer during the exam there. So we will give you these equivalent quantities there. You just need to know how to do calculation. And of course, it's not just within the metric system. It's sometimes they ask you to convert from the English system to the metric system there. So these conversion factors are not something that we need you to memorize, and rather we will give it to you. 1 gram, 1 inch equals to 2.54 centimeter. 1 pound equals to 453.6 gram, and 1 liter equals to 1.057 mol. Now, again, these conversion factors are treated as exact numbers. So when you're doing the conversion here, this number has 1 digit, but this is not the measured quantity. This is the exact number. When you do the conversion there, going from here to here, you have 2 sig figs. So you don't just write down 0.3, rather, even though this number here, 1, only has 1 digit there. So these are, the conversion factors are the exact numbers. They do not participate in the process of determining the sig fig in your final answer. That's something that I cannot overemphasize, because every time when we're doing the conversion, there's a, oh, wait a minute, there's digits in here. Well, whenever you use a conversion factor, remember that's an exact number. Okay, so you don't need to memorize these quantities there. The list that I showed you previously is not an all-inclusive list. You can even come up with your own list. Okay. But if you click on the final exam on Canvas there, okay, there is an information package for the final exam there, and you will be able to see the list of equivalent quantities given to you in addition to the periodic table. So you may want to spend a little time today after class there and check it out. Just make sure you understand what are the things that will be given to you. Then the rest of it is something that's probably you need to memorize. Now I guarantee you, for any conversion that we ask you to do, we don't need you to memorize the conversion factor. You will be given the primary conversion factor. And all you need to do is to be able to figure out sometimes the secondary conversion factor and be able to use it when you're doing the calculation. Okay, so talking about the conversion factor, now it's time for us to actually use conversion factor to do some exercise there. So this is the term that we use, dimensional analysis. A matter of fact, in this particular course, 99% of the calculation is dimensional analysis. How do you do dimensional analysis? You are converting one set of unit into another. All you need to do is to identify conversion factor. Once you identify the conversion factor, you always multiply the quantity you're trying to convert. You always multiply the conversion factor, setting it up in a way that you can clearly see the unit you don't want cancels out, and will leave you with the unit you do want. Okay, so that's our last learning objective for this particular chapter there. And we're going to talk about how do we do conversions. And the best thing to learn about the dimensional analysis is to do different types of calculations there. So here we're talking about, in chapter 1, we're talking about definition of matter, classification of matter, and definition of physical change, chemical change, and pure substance, mixture, that kind of thing. Now we're getting into measurement and conversion. Okay, so that's another part of the chapter 1 there. So when we do dimensional analysis, what is dimensional analysis? We say, well, to convert measurements from one set of unit to another. That's a definition. I probably won't ask you to define dimensional analysis. All you need to know is what we're doing, dimensional analysis, how to do dimensional analysis. That's more important than the definition itself. Okay, so we also call it factor label methods. All we need you to do is to identify the correct conversion factor, setting up the equation correctly, cancel out the unit you don't want. Okay. Your textbook has a very good approach on this particular issue when you do dimensional analysis. There's a step-by-step setup on the calculation for the calculation, and then you see where the unit cancels out. And we will do a series of practice in class today to show you how to set up the equation. And then after the lecture today, you keep this in mind. I will always say this, whenever we introduce a new type of calculation, I will say that this is just another dimensional analysis. All you need to do is to identify the conversion factor. Once you can do that, the rest of it is easy. The rest of it is just math. When you set up the equation, you cancel out unit you don't want, you end up with the answer, hopefully the correct answer. Okay, so there's nothing more, nothing new in the calculation there. Chemistry is actually, at this level, actually quite easy. Dimensional analysis and definition. That's pretty much what it's all about. Okay, so how do we determine conversion factor? And we talked about this earlier. So in this case, when you do dimensional analysis, we need to use conversion factor. Now conversion factors are something that we basically list of equivalent quantities that will be given to you. So one of the conversion factor, we use this as an example. 1 meter equals to 100 centimeters. Now, we can write this conversion factor in this way. 1 meter on top, 100 centimeter on bottom. Or 1 meter on bottom, 100 centimeter on top. Which conversion factor are you going to be using? Well, that depends on what unit you are converting from. If you are converting from centimeter to meter, remember we asked you to always multiply the conversion factor. If you're converting centimeter to meters, the centimeter has to be on the denominator so you can cancel them out, leaving you with meters. So you use this conversion factor. In a sense, you divide the quantity by 100. Okay? If you're converting from meter to centimeter, well, you put the meter in the denominator, multiplying this quantity, this conversion factor by the quantity in meters, meter cancel out. Now we'll give you the centimeter. So in this case, you multiply it by 100. So when I was learning dimensional analysis there, it says, well, sometimes you divide 100, sometimes you just multiply by 100. Well, that's kind of confusing. Let's just make sure when we have an equivalent quantity given here, these two are what we call conversion factor. The same conversion factor, but with the units in different places there. Always remember when you do conversion, when you do dimensional analysis, we always multiply the conversion factor. Okay. Now we just need to make sure that we focus on the units there. And I think after many years of teaching, I think this is probably easier for everybody to remember. Because some of you may still get used to, sometimes you divide, sometimes you multiply. And if you can get that, great, as long as you get the correct answer. Okay. But for everyone that